Alright guys, today we're going to talk about simplifying polynomials by addition and subtraction. So on number 1, 2, and 3, it's just kind of a quick review over what we did last chapter. So on number 1, we have 3x plus x. Remember, to be able to add terms together, they have to have the exact same variable raised to the exact same exponent. So since this is x to the first plus x to the first, I can combine those, and I say that's 4x. Now we don't add the exponents, we just combine them. For example, if I were to have 3 red balls and I were to add another red ball to them, that would just give me 4 red balls. Alright, now on number 2, I'm multiplying 4x times x. This is when you have to do a little bit of work with the exponents. Now, when you multiply the terms, you multiply their coefficients just like normal. So I have a coefficient of 4 and a coefficient of 1. 4 times 1 gives me 4. But when I take x and multiply it by x, I have to add their exponents to get x to the second power. On number 3, I have 5n squared times negative 6n squared. So I multiply the coefficients like normal, and 5 times negative 6 gives me negative 30. And I have to add those exponents, and n squared times n squared gives me n to the fourth. So when you add terms together, they have to be like terms. When you multiply them, that's when you add the exponents. On number 4, they want me to add polynomials by combining like terms. So on number 4, I have 8x squared plus 5x minus 4 plus 6x squared plus 2x minus 3. So I have a trinomial being added to a trinomial. Now to do this, all I have to do is combine like terms. So first, I have an 8x squared here. To be able to add that to anything, it also just has to have an x squared. So if I go through and I look, here I have a 6x squared. So I can add those two together and come up with a 14x squared. So we just changed the coefficients, not the exponents. Now that I'm done with those, I'm going to cross them out so I don't use them again. The next thing that I see is a positive 5x. So to add that to something, it also has to have an x to the first. So if I go through and look, here I have another x to the first. So I have a 5x and a 2x, which I can add together to come up with a 1x, or 7x, goodness. And then I cross those out. Next, what I'm left with is a negative 4. Now this is just a constant because it doesn't have a variable, so I can only put it with other constants. So here I have a negative 3, which is also a constant. Notice the sign in front of them went along with it. So negative 4 plus negative 3 gives me a negative 7. Now the last thing that I need to do before I move on is double check that this is in standard form, which means that it has to be in order from highest degree to lowest degree. So this term had a degree of 2, this term had a degree of 1, this term had a degree of 0. Well, that is definitely in order, so we're good to go in standard form. On number 5, I have m squared plus 3m minus 12 plus m squared minus 8m plus 3. So again, I can only add like terms. So here I have an m squared. To be able to add that to anything, it can only be an m squared, like here. So m squared plus m squared is 2m squared, and I cross them off. Then the next thing that I see is an m to the first power. Here's an m to the first power, and here's an m to the first power. So a 3 and negative 8 gives me negative 5m, and I can cross them off. Then I have a constant negative 12 and a constant 3. I can add those together, and I get negative 9. Finally, before you move on, double check that it's in standard form. Degree of 2, degree of 1, degree of 0, we're okay. Let's try it again on number 6. So I'm going to start with a 7x squared. So to be able to combine that with anything, it also has to have a degree of x, or a term of x squared. So here I have a variable of x squared. I can add those together and get 9x squared. Then cross them out. Next, I have a 3x. So to add it to anything, it has to have an x to the first. So 3x plus 5x gives me 8x. Then I see that I have a constant of 9. Here I have a constant of negative 2, and I can add those together and get a positive 7. Next, what I'd like you to do is pause the video and try number 7 on your own. Hopefully, you saw that this guy can go with this guy and give me a positive 5x squared. This guy can go with this guy and give me negative 3x. And this guy can go with this guy and give me a negative 11. On number 8, I'm working with a little bit different variables, but that's okay. I start off with a 6x cubed and a 3x cubed, and I can add those together and get a 9x cubed. Okay? Then I see a 2x squared and a negative 10x squared, which can give me a negative 8x squared. And finally, I see a negative 3x to the first and a negative x, and that gives me negative 4x because they have like signs, so we add them together. Now double check that it's in standard form. I have a degree of 3, 2, and 1, so we're okay. On number 9, we've got a couple of different variables in the mix, and that's okay. What needs to happen is they still need to have the exact same variables raised to the exact same power. So here I have an x to the third power being multiplied by a y to the first power. I can only combine that with a term that also has x to the third and y to the first. So this guy has an x squared, so right away that doesn't work. This guy has an x to the first, so that doesn't work. This guy has an x to the third, so we're on the right path, and a y to the first. So that is what I can add together. Let's go through and make sure that there's none others. X squared doesn't work, x to the first doesn't work. So I can add these two together and say that I have 3 of those x to the third, y to the firsts. The next thing that I notice is I have a 3x squared y squared, so I can only combine that with other x squared y squareds. This doesn't work. This does work, so make sure you get the sign in there with it. And this doesn't work. So if I have 3x squared y squared and negative 9x squared y squared, I have negative 6x squared y squared. Finally, I have a 2xy to the third, and if I look, my remaining term is a negative xy to the third. So I can combine those and I get a positive xy to the third. Now let's double check that this is in standard form. The degree of my first term is 3 plus 1, which is 4. That's not a 4. The degree of my second term is 2 plus 2, which is 4. And the degree of my third term is 1 plus 3, which is a 4. Now they're all the same number, so it doesn't matter what order it is in, so what it's in now is fine. The next thing I want to talk about is what happens when we subtract polynomials. Subtraction is a little bit more difficult than addition. Addition is very easy because you can just put the terms together and get a resulting number. Subtraction involves a little bit more thought process, so my goal is to make it easy like addition. Well, to make it easy like addition, let's just turn it into an addition problem. And to do that, we need to distribute and then combine like terms. Here's what I mean by that. On number 10, I have 3n squared minus 5n minus n squared plus 2n minus 8. Notice the subtraction sign is by this entire polynomial. So that's really kind of like saying I'm adding a negative 1 times n squared plus 2n minus 8. So if I distribute that negative 1, all I'll be left with is the addition sign, and I won't have to worry about that subtraction sign. So to start this problem off, we're going to distribute that negative symbol throughout my second polynomial, and then we can just add our terms together. So to start off, I'm going to bring down my first binomial, this 3n squared minus 5n. Then I'm going to put a plus sign. And in my second polynomial, I want to distribute that negative sign and change all of the signs of each term. So instead of a positive n squared, I'm going to have a negative n squared. Instead of a positive 2n, I'll have a negative 2n. And instead of a negative 8, now I'll have a positive 8. So now, instead of a subtraction polynomial, I've got a nice addition of polynomials and can combine like terms. So, like we did up top, 3n squared can go with a negative n squared to give me 2n squared. Negative 5n can go with negative 2n and give me a negative 7n. And now if you'll notice, I only have one term left, which is a positive 8, so that can come along for the ride. Now double check that it's in standard form, degree of 2, 1, and 0, and we're good to go. Let's try it again on number 11. Again, I'm subtracting the second polynomial, so I want to rewrite this. I'm going to bring down 5a squared minus 6a plus 1. And instead of a subtraction sign, I'm going to have an addition sign. And now my second guy, all the signs on the inside are going to change. So I'll have a negative 2a squared, a positive 3a, and a positive 2. So now I have a nice trinomial being added to a trinomial. Why don't you pause the video and combine your like terms on number 11. Hopefully you added 5a and negative 2a squared to get 3a squared, negative 6a and 3a to get negative 3a, and 1 and 2 to get 3, which is in standard form. On number 12, again I'm going to distribute that negative symbol. So I'll be left with 2x squared plus 3x plus 8 plus, now we can distribute my negative symbol, the quantity of negative x squared minus 5x plus 1. Now, again, pause the video and combine your like terms. Hopefully you got x squared minus 2x plus 9, because these two go together, these two go together, and these two go together. Next, what I'd like you to do is pause the video and do number 13 completely on your own. Hopefully, you distributed and got your second trinomial to be negative 9x squared plus 4x minus 4, and then you combine your like terms and got negative 10x squared plus 13x minus 6. On number 14, let's start by distributing that negative symbol. So I'll still be left with x to the 4th plus 8x squared minus 1, but now I'll be adding a negative x squared plus 3x cubed minus x to the 4th. Now, let's combine our like terms. So I have an x to the 4th here, and it looks like I've got an x to the 4th over here. But if you'll notice, this one's positive 1 and this one's negative 1, so they really just cancel out. The next thing is I have an x to the 1st here. Well, I don't have any other x to the 1st, so that 8x is going to come down. Then I notice that I have a constant here. Again, I don't see any other constants, so this guy's just going to come down. Next, I have a negative x squared. Well, again, I don't see any other x squared, so I'm just going to bring it down. And then I see a 3x to the 3rd. Well, there's no other terms left, so again, I just have to bring that guy down for the ride, and I'm left with 8x minus 1 minus x squared plus 3x to the 3rd. Well, that's okay that I didn't have any terms really to combine except for the x to the 4ths, but what's not okay is this is not in standard form. I need to rewrite it in order from highest degree to lowest degree. So this has a degree of 1, 0, 2, and 3. So this guy needs to go first, this guy needs to go second, this guy will go third, and I'll be left with my constant going last. 3x to the 3rd minus 2x plus 8x minus 1. On number 15, let's start by distributing that negative symbol throughout my second set. So I've got 3x squared plus 7xy minus 2y squared plus negative x squared plus 6xy minus 2y squared. Now I can combine my like terms. So I'm going to start with this 3x squared. Notice here I have a negative x squared that I can combine it to, and I'll be left with a 2x squared. Then I have a 7xy. So here I have a 6xy I can add it to, and I'm left with 13xy. Finally, I see that I have a negative 2y squared and a negative 2y squared. They're the same, but unlike number 14, they have the same sign, so I have to combine them to get a negative 4y squared. Finally, let's make sure it's in standard form. This has a degree of 2, a degree of 2, and a degree of 2, so we're okay.